Hello, my name is Jeff Bowles. Welcome to PMI's technical webinar series. Just some housekeeping to touch on before we begin. All attendees will be muted during the entire webinar. We will have time at the end of the presentation to answer any questions you may have. For questions related to the presentation topic, you may type in and send questions at any time during the webinar. You may use the chat function, which is separate from the questions function, for any other comments you may have. The webinar will last a total of 1 hour and 15 minutes. If you are having trouble with your sound, you may switch from computer to phone or the reverse as needed. Okay, let's get started. Again, my name is Jeff Bowles. I am the Risk, Safety, and Industry Relations Manager for Pigeon Mountain Industries and the host of today's PMI Technical Webinar Series. This presentation will outline recent updates to the OSHA Fall Protection, the recent OSHA Fall Protection regulation, as well as developments within the ANSI Z359 family of fall protection standards as it relates to rope access. Presented by PMI's Loui McCurley, who has been blazing new trails in safe work at height for over 3 decades. This is a command performance updated to her presentation at the January 2017 SPRAT conference. From working as a rope access technician before such a thing existed in the USA, Loui visualized and instigated the founding of the Society of Professional Rope Access Technicians in 1996, then went on to help develop a pair of groundbreaking global rope access standards with the International Standards Organization, or ISO, in 2003. 10 years later, she worked tirelessly with OSHA to ensure allowances were made for rope access in the impending 2016 updates to their 29 CFR 1910 Subpart D Walking Working Surfaces Regulation, and recently released the first book of its kind on professional rope access for safety professionals and program managers. Today, in addition to serving as Regulatory Assistant Chairman of SPRAT, Loui is once again leading a charge for the cause as Chairman of the ANSI Z359 Committee's forthcoming standard on rope access. Loui's commitment and passion to improving safety in the work at height is recognized by regulatory authorities, standards organizations, and corporate safety professionals worldwide. You'll get the latest critical updates and insights towards future efforts. And without further delay, I present to you Loui McCurley.
Thanks, Jeff. I first just want to thank everybody for taking the time to be here today. It's really cool for me to see so many people interested in rope access and actually so many people using rope access today. So thank you for taking the time to be here and for taking the time to engage in this conversation about implementing rope access into a comprehensive managed fall protection program. Understanding the management of rope access and integrating that management into our overall fall protection programs is really the nemesis of rope access today, and it's the piece, you know, we've busted through a lot of limitations as far as having certified technicians, having a certification program, having lots of work going on with lots of safety, but this management piece is still kind of the part that that's bugging us a little bit, and the part that we need to expand on. So thank you. We're going to cover a lot of ground today. We're going to try and establish a baseline for understanding rope access, because I don't know who you are or what your experience is in rope access, although I'm going to question you on that here in a minute. But then we're also going to spend some time talking about how OSHA's 2016 modifications to the Walking Working Surfaces Subparts D&I regulations are relevant to us as rope access technicians. So what I've planned to cover here in the presentation are some of the more common questions that I've been getting about this over the last year or so, but keep in mind that this is like no way all-encompassing. So there's a lot more information than we're going to be able to get through today. So if by chance you have a question that isn't covered, enter it in at the time that, or for the questions at the end, and or give me a call later and or contact me on LinkedIn or whatever, and let's discuss that stuff. So again, the purpose of the presentation is really from an operations and a management perspective. We want to understand what OSHA says and what industry standards say about rope access. And then we want to compare those conventional fall protection methods with rope access, and then align our comprehensive managed fall protection program with our rope access program alongside of the other methods of fall protection that we use. So that's really the target that we're shooting for today. Now, we're doing this in context of OSHA. When we talk about regulatory requirements, at least today in this presentation, we're going to speak in terms of OSHA. We're going to do that because I happen to be sitting in the United States right now, and OSHA has jurisdiction here. So OSHA was created by Congress under the Occupational Safety and Health Act, and the idea behind OSHA was we didn't want to hurt any more employees. So we wanted to stop people from getting hurt at work, and so that's why OSHA was created. Now they do this by establishing standards, enforcing standards, and then they also have some technical assistance and consultation programs that you can use to help you comply with OSHA. There's a whole bunch of inspectors out there, and I think one of the most feared things with rope access at the moment is whether or not OSHA fully understands rope access, and again, that's kind of where we're coming from today, and part of the target for today is to kind of blend that whole insight. OSHA has jurisdiction over workplaces in the United States, with a few exceptions. The government doesn't fall under OSHA. City and county, federal, state don't fall under OSHA. Anybody that falls under another regulatory authority like NTSB or Mine Safety, MSHA, people like that don't fall under OSHA. Family members working on a family farm, or sole proprietors with no employees, and volunteers. These don't fall under OSHA. Does that mean that the OSHA regulations aren't good to follow? No, you should definitely at least be aware of them, even if you fall into one of these categories, because often what OSHA is citing is industry best practice. So before we get started actually talking about what OSHA says about rope access, I would like to understand who you are, and I'd like to understand who we're talking to here. So how are you involved in rope access? You'll see a little poll coming up on your screen, and it asks how you're involved in rope access. And what I'm looking for is just to understand, are you a rope access technician? Are you somebody who's out there working? Are you an employer of technicians? Are you a safety manager? Are you a safety manager for fall protection in general, or just for rope access? Now, I know this is going to apply to multiple questions, or answers are going to apply to most of you. So pick the most relevant one. If you're a rope access technician and a safety manager, then put safety managers, so that we can kind of get an idea of what's your biggest interest today. What's the main thing that you're trying to get out of this presentation? So in general, it kind of looks like the majority of people are safety managers for fall protection organizations. We also have a whole lot of certified technicians. We have maybe a fifth of the group that isn't rope access at all yet, or maybe about a fifth of the group is not yet involved in rope access. So we've got a real broad representation here. There's most of you, there's an even split pretty much between certified technicians, safety managers, and people who are not yet using rope access technicians or for work. So that's good. Thank you for helping me with that. That actually helps direct the conversation today. And again, as we go through, don't hesitate to go ahead and type any questions that you might have into the question portion of your dashboard, and we can collect those throughout the entire presentation. So I'm going to go ahead and close this poll now. Understanding your responses, and I will share that. Oh, I can't do that. Yeah, maybe I can. So those are the poll results. You should be able to see the poll results now. So let's talk briefly about what OSHA says about rope access. The basic foundational guidance that OSHA provides obviously is not specific to rope access. It's just a general requirement that requires some thoughtful consideration in order to achieve compliance. In general, we're told that we have to furnish to employees a safe place of employment where recognized hazards are not existing or have been removed from the workplace. Now, that's important because what OSHA is essentially saying is that employers need to protect our employees from anything at work that might cause them harm. And sometimes that even means protecting them from themselves, from poor decisions that they might make as a result of exposure to something that they're not familiar with, or even just something they might get their fingers into that they really shouldn't be doing at all. So work at height obviously can fall into that category, particularly for an untrained person. The specific duty clause of OSHA goes on to say that employers have to comply with any specific regulations that they have relating to a specific hazard. Now, again, although OSHA doesn't necessarily write standards for every hazard, they do put the onus on the employer to recognize those potential hazards and then figure out whether OSHA has something that applies. In our case, work at height is obviously something that OSHA has recognized and they've written specific regulation about. Today, we're going to focus on the regulations that they've written into the general industry requirements found in 29 CFR 1910. Now, requirements for construction are found in 1926. They're a little bit different in some cases, but OSHA is working really hard to better align the two. Now, as part of that effort, this revision to subpart D that they made in 2016 actually kind of paves the way a little bit between these two regulations. This is the first update that OSHA made to fall protection regulation in like 30 years. So it's a really big deal. They revised subpart D and that had some fallout into subpart I. But in short, it applies to all elevated working surfaces. It does address fall protection systems of all kinds, and it increases the performance-based language. And I think that's probably my favorite part about their revision, is that it really focuses on a performance-based approach, which is great for us as rope access technicians. There's just a few of the sections of the revision that contain information that are pertinent to rope access. So these are the areas that I'm going to focus today. The areas that I'm going to focus today are the ones that are highlighted here in red. Now, if you haven't actually taken the time to go to the Federal Register and read the final rule, including the prologue and supplementary information and all of that, I highly recommend that you do so. As a safety manager, understanding OSHA's intent and approach to regulation is really just as important as understanding the regulation itself. In fact, kind of maybe even more so. I understand that you cannot see my presentation. I apologize for that. I can't tell if the poll results are still up now. Maybe you can just type into your chat box whether you can see the presentation again. Can you just type into the chat box whether or not my screen is visible to you guys? Obviously, my goal.
Loui, I hid the poll results, and there we go. It's coming up now.
All right, cool. I apologize for that, guys. So the link at the top here is where the full OSHA presentation or where the full rule can be found. But the easiest way to get there is to go to OSHA.gov, and there's a walking working surfaces, go / walking working surfaces. And from that link, you'll actually be able to get to several different sections of the walking working surfaces rule, including the Federal Register. And reading the prologue and reading all of the information relative to that will really help you understand where we're going where OSHA's going with fall protection and with rope access in general. And it is very helpful. I'm going to leave that link up there in case you're scribbling it down quickly while we talk about a couple of things like scope and definitions. So when OSHA wrote their new rule, they put some definition to the terms fall protection and personal fall protection systems. Understanding the definitions is essential to understanding the context of how OSHA expects you to comply. Here's the key. It doesn't really matter if you agree with OSHA's definitions. I've talked to a lot of people since the 2016 release that don't like the definitions, or they think that OSHA should have written the definitions differently or used different terms or whatever. But here's the deal. We're all entitled to our own opinions, but we're also required to comply with regulation as it exists, whether we like it or whether we agree with it or not. So we need to understand the definitions as they exist. So fall protection refers to any equipment, device, or system that prevents an employee from falling from an elevation or mitigates the effects of such a fall. That's fall protection. Personal fall protection system means a system, including all its components, that an employer might use to provide protection from falling or safely arrest an employee's fall if it occurs. Now, examples of personal fall protection systems might include personal fall arrest systems, positioning systems, restraint systems. What this means is personal fall protection systems are a type of fall protection. So it's almost like a subcategory of fall protection. Inside of that, fall arrest, positioning, restraint, rope descent systems, rope access even, are types of personal fall protection systems. Again, I guess you could kind of say that a thing becomes a personal fall protection system once a person puts on a harness. So if we paraphrase that, we could say that today we're going to focus on harness-based systems in our discussion, in our presentation. So within the context of fall protection as a whole, there's several types of harness-based fall protection systems that you might be able to choose for work. If you look at this graphic, if you think of the whole white on the background representing fall protection, then more specifically, the personal fall protection systems are the things that are named along the lined circles. So those would be examples of the kinds of things that OSHA is addressing as personal fall protection systems. Now, this is going to become important as we talk about which rules apply to which kinds of fall protection later on. So the kinds of things that they addressed as personal fall protection systems include travel restraint, positioning, personal fall arrest, and rope descent. Rope descent is a new type of fall protection, personal fall protection system. Has never really been addressed by OSHA before. This is new to OSHA regulation. In addition, they've also left room for other types of personal fall protection systems, such as rope access. Rope access is not named in the regulation, but it's not excluded either. So here are OSHA's definitions of some of the different kinds of personal fall protection systems. Travel restraint is essentially a leash that prevents you from getting to an edge and falling over. Positioning is a type of equipment that keeps you in suspension or allows you to be supported and still work with both hands free. But with positioning systems, you typically are also still using your feet, and you must also use a fall arrest system in conjunction with that. A personal fall arrest system is a system that is used to arrest an employee in a fall from any kind of a surface. So those are the old-fashioned, basically the types of fall protection that we've dealt with for the last umpteen years. The new one in the family is rope descent. OSHA defined rope descent as a suspension system that allows an employee to descend in a controlled manner, stopping at any point during the descent. It usually consists of, and this is how they defined it, a roof anchorage, a support rope, a descent device, carabiners or shackles, and a chair or seat board. Now, the reason that they used this terminology is because they took most of their rope descent rules from the window cleaning community. So they was very specific to window cleaning. And even OSHA acknowledges and recognizes that as they point out that their rope descent systems do not include industrial rope access systems. And we're going to go through that in a minute. So as we talk about rope descent as a specific type of system, let's talk about the things that exemplify rope descent. What does a rope descent system look like? Well, in a rope descent system, the descender is usually attached to the seat board, not to the individual or his harness. In rope descent, conventional fall protection is typically, but not always, used as a backup. It's typically down only. A rope descent, a person using RDS typically does not have the ability to go up or sideways on the system. In rope descent, there are minimal levels of training that are specified. There's no certification required. There is a 300-foot height limit that is imposed on rope descent. There's also a stabilization requirement whenever you get above 130 feet. And there's a certified anchorage requirement as well for rope descent. And then, of course, some means of rescue is required, and that's true for all types of work at height. So these are the things that exemplify rope descent. This is what a rope descent system essentially looks like. So now we have to kind of consider what the differences are between rope access and RDS. Now, in the new rule, OSHA does make it clear that rope access is considered a viable and acceptable method of fall protection, even though they don't set aside specific requirements for it. Their definition for RDS says rope descent systems do not include industrial rope access systems. So that's actually in the regulation. The preamble goes on to say, as such, 1910-27 does not cover or apply to industrial rope access systems. However, other sections of the final rule do cover industrial rope access systems. So what you can read into this is industrial rope access systems are not disallowed simply because they're not named or don't have specific requirements around them. It just says that when you do use rope access, it needs to comply with all of the general requirements of the new rule. And beyond that, you kind of have to look to industry best practice to figure out what you're supposed to do or how to do it safely. The onus is on you as the employer to make sure that you're using rope access correctly and appropriately. But we're going to go into that a little bit more in a minute. First, let's talk about some of the things that make rope access, that differentiate rope access from RDS. First of all, rope access always incorporates dual interchangeable systems. Your primary and your backup can be interchanged at any time during the course of work. The rope access backup that is used is specifically a rope access backup. We're going to get into that in a minute too, but it's not a conventional fall arrest system, so it's not a conventional backup. It's typically multi-directional. You have to be able to go upwards as well as downwards on the rope. You can typically go side to side if there are other ropes available or deviations available. We always use certified technicians to do rope access. So technicians that not only have training and knowledge, but that their training and knowledge has been verified in some way. The oversight and management has to be specific to rope access. So somebody who understands rope access has to be providing the oversight and management. That doesn't mean you have to be a rope access technician. It just means that as a safety manager, you have to have educated and informed yourself as to what rope access what rope access is and how it's managed differently from conventional methods. There are no overarching height restrictions in rope access. And again, there's always a self-rescue or partner rescue capability required. So in short, rope access is not specific to any one industry. It's a method of protection and a method of access that can be used in any industry to perform any kind of work. So it's just one more tool in your toolbox that can be used for safety. It is not an industry in and of itself. It is not specific to window cleaning or to wind turbines or to towers or anything else, but it can be used in all of those and more. So remember earlier, we alluded to industry best practice, and I said I was going to get back to that as being one of the measuring sticks that we use to determine the appropriateness of how an employer or a safety manager is implementing rope access. The idea behind industry best practice is that employers need to not only comply with basic equipment requirements that exist in regulation, but you also have to remain aware of commonly accepted best practices in the workplace. So according to national and international standards, rope access is kind of set apart by three distinct characteristics: the methods and skills that are used, the equipment that's used, and the management and oversight. So we're going to address these one by one. We're going to start with methods and skills. So for rope access, special skills are obviously required. In general, it's preferred that you be third-party certified. Now, is it required that you be third-party certified? I guess that probably depends on who you ask. But according to most regulatory requirement, if it isn't written down, it didn't happen. And a third-party verification is always more verifiable and always more affirmable, provable than something that you do in-house. Professionally trained technicians that are certified through the SPRAT or other rope access programs typically receive extensive training, like 40 hours or so, and they pass a rigorous evaluation in order to be awarded that certification. And then if they don't continue to work in rope access and log hours as rope access technicians, they have to undergo retraining. Now, the cool thing about that means that you not only have training and knowledge, but you have experience as well. This is really part of an important part of the safety of rope access. Some of the key considerations in rope access is that there's always a primary and secondary line. Those lines are always interchangeable, and the equipment has to be able to come on and off the rope relatively easily in order to facilitate transitions. One of the skills, or one of the key skills, is descending. Obviously, we have to be able to descend to do a rope access system with that primary and backup interchangeability. We also need to be able to ascend. Your ascender is on your working line, while the safety is provided by a backup system on a secondary line. Using these two basic skills as a starting point and changeovers as kind of the next piece, technicians learn how to change between ropes for both the primary and secondary systems. So because of this, the frontal attachment point is absolutely essential to rope access. If you're using a dorsal attachment, it's quite difficult, if not impossible, to do rope access. So that's why we say that a rope access technician is only doing rope access when he's using that front attachment point. When he's using the dorsal attachment point, he's essentially in RDS. That front attachment point is also essential for aid climbing. Aid climbing is a rope access technique whereby a worker moves across a beam and he's never attached to fewer than 2 anchor points at any given time. Same principles apply to deviations and re-anchors, which are important when work isn't neatly aligned. You can re-anchor your ropes to mitigate swing fall potential, which is something that we typically don't see in conventional methods. Rope access also doesn't always, but can incorporate lead climbing so that a technician can get to a high point to place an anchor. And so doing so, he uses an active belay system to get to that point. And then always, unquestionably, all trained and certified rope access technicians are required to be capable of performing self and partner rescue. This, again, is an essential part of the rope access technician's repertoire. And then there's also a requirement to be able to transition safely with conventional fall protection. Whenever we're doing rope access, we're never just in rope access. We're usually also transitioning back and forth between positioning, restraint, and even occasionally fall arrest. So having touched on the skills and methods, let's talk about equipment for just a moment. And here we're going to address kind of some of the OSHA regulations a little bit more. Remember earlier we talked about OSHA's new regulation and how it addresses requirements in 2 realms, one applicable to personal fall protection systems in general, and then with specific requirements for a few unique types of personal fall protection systems, such as positioning, fall arrest, things like that. So understanding, again, I want to emphasize this general catch-all term, personal fall protection systems, establishes a backdrop of requirements to which all fall protection equipment must comply, whether it's restraint, positioning, arrest, rope descent, rope access, or anything else. So any personal fall protection system has to comply with these general fall protection requirements. As we talk about equipment, keep this in mind. This context is really important. Rope access gear does not need to necessarily comply with criteria called out for fall arrest, for example, but it does need to comply with the criteria set forth for the general topic of fall protection. And this is kind of one of the big things that if we don't plant this early and really understand this, it can mess us up later as we strive to understand the requirements. So requirements. One of the requirements that OSHA put, general requirements that OSHA put on personal fall protection systems in general, is that of connectors. Connectors are required to be drop forged, pressed or formed steel, or equivalent. They have to be corrosion resistant. They need to be auto locking with 2 separate consecutive movements to open. They have to be proof tested, and that's a bad term. I should have taken that out of there. Sorry. They have to be certified or confirmed to a minimum tensile strength of 3,600 pounds, with the gate proof tested to 3,600 pounds in all directions. So you have to not be able to open it with less than 3,600 pounds in any direction that you pull the gate. And again, that's not proof tested, as in every carabiner that you buy has not been subjected to that load. It's only verified testing that confirms that that's the strength of the equipment. Connectors in use in any personal fall protection system are not allowed to be connected to webbing, rope, wire rope, each other, a D-ring where something else is connected, a horizontal lifeline, or any other object unless it's designed for such a connection. So this is kind of a hard one to understand. It says it can't be connected to any of the following, but then there's a unless it's designed for such connections. And so one of the things that we run into in rope access here is often we have connectors connected to the same D-ring. For your positioning system on your waist, for example, you typically have multiple carabiners and connectors attached to that D-ring at all times. So if it's designed for that, it's okay. That's what OSHA is saying here in their rule. OSHA also put some general requirements over personal fall protection systems, vertical lifelines and lanyards. So again, this is for all personal fall protection systems. The vertical lifelines and lanyards used in any personal fall protection system has to comply with these requirements. Each employee has to have his own. Each of them has to be 5,000 pounds in strength. The self-retracting lifelines have to limit free fall to 2 feet, and they must be 3,000 pounds strength in the fully extended position. And knots have to be inspected by a competent person or qualified person before use. Now, that last bullet point there kind of addresses something that used to be a problem, or used to be a big misunderstanding in OSHA, where it was perceived, and in some cases it was true, that knots were not allowed to be used. The regulations that was written under back in the day when OSHA wrote the rule that said knots can't be used, we were using manila rope, and things were very different 30 years ago. So today, knots can be used as long as they're inspected by a competent or qualified person before they're used. Lifelines may not be made of natural fiber rope. Oh, we were just talking about that. Anything that's a polypropylene rope must contain a UV inhibitor, and then you have to protect all your soft goods from damage. Now again, these are requirements that apply to all personal fall protection systems. There are also some requirements around anchorages that pertain to all personal fall protection systems. Anchorages have to be independent of any other anchorage that is used to suspend employees or on platforms. So you can't use the same anchorage for fall arrest that you also use for to suspend your powered platform. The anchorage has to be at least 5,000 pounds strong for each employee attached, and it has to be designed, used, and installed under the supervision of a qualified person as part of a complete personal fall protection system. Travel restraint. Now we're getting into, we're still talking about personal fall protection systems in general. This is in the personal fall protection systems general requirements section, but it does talk specifically about restraint in that section, and it makes an exclusion, and it says that lines have to be capable of sustaining a tensile load of at least 5,000 pounds. Also in the personal fall protection general requirements section, fall protection equipment has to be used just for fall protection. You can't also use it for hoisting equipment or products. Fall protection equipment that gets fallen upon needs to be removed from service. That ought to be kind of a no-brainer for everybody here, I would think. And then every system has to be inspected before initial use during each work shift. And then, of course, all equipment has to be compatible. So these are all things that most people do anyway, but they did get written into the rule where they weren't there before. Another requirement is that the employer must provide for prompt rescue of each employee in the event of a fall. That means that you can't just have one guy trained in rescue on the site, because if he's the one that falls, then who's going to rescue him? So every employee has to be able to be rescued if something bad should happen. Personal fall protection systems have to be worn with the fall arrest point near but basically in the dorsal position, but it may be in the pre-sternal position as long as you have a short free fall. Now we get into some specific requirements. Now, all of those requirements that we just talked about apply to all fall protection systems. These requirements here apply just to personal fall arrest systems. And those requirements include limiting the arrest force to 1,800 pounds. That's the maximum arrest force to 1,800 pounds. The system has to bring the employee to a complete stop. The max deceleration distance can't be any greater than 3.5 feet. The system has to be strong enough to withstand 2 times the potential impact energy. The employee has to be caught without making contact with his neck or chin. And there are allowances made for employees over 310 pounds. So that too is a new requirement that is very useful for some. Also, in personal fall arrest systems, the employer has to ensure that horizontal lifelines that might become a vertical lifeline, the device has to be able to lock in both directions, so it can't be accidentally misapplied. The systems also have to be rigged so the employee can't free fall more than 6 feet or contact another level. These are, again, requirements. Those were requirements, sorry about that, for personal fall arrest systems. Let's talk now about rope descent systems. We're getting just a little bit closer to rope access here. We're not at rope access, but we're getting closer. In rope descent systems, OSHA says that the anchorage has to be certified to 5,000 pounds, and there must be written permission to use that certified anchorage. The use of personal fall arrest system is required above 4 feet. Everybody has to be on their own system. Everything has to be rated to 5,000 pounds, and the seat board, except for the seat board, which has to be at least 3,000 pounds, or 300 pounds strong. In rope descent systems, there's a height requirement of 300 feet. So people using RDS are not allowed to go above 300 feet unless there's no other way to do the work. The system has to be used within the limitations of the equipment that's being used. The training has to be in accordance with OSHA reg. Systems have to be properly inspected, rigged, tied back. Prompt rescue has to be provided for. And then, of course, soft goods have to be protected. So again, some of these are pretty obvious. The protection of soft goods, the prompt rescue, the proper rigging, that's kind of a no-brainer. The 300-foot height limit, it's given some people some headaches. In rope descent systems, it also says that intermittent stabilization is required when descents are in excess of 130 feet. Now, this comes from powered platform rules, and it's a little harder to do in RDS, and we're going to get into that just briefly here in a second. It's also not allowed to be used when hazardous weather conditions are present. Equipment has to be secured, and the ropes have to be protected from anything that might corrode or destroy them. Now, in this rope descent systems section, there are some things that people kind of consider onerous requirements. So things get a little bit interesting at this point. Beyond the general requirements that we talked about earlier that apply to all personal fall protection systems, OSHA focuses largely on system performance, which is really cool. But then when it comes to RDS, they've put some of these specific requirements in that were originally penned by standards that don't really exist anymore, like ANSI A39 and ANSI I14, window cleaning standards. Those standards aren't even really on the streets anymore, but some of the language got adopted and drawn over from those standards. And ironically, the language that got included in this regulation are actually the primary reasons that those standards don't exist anymore. For example, the anchorage being certified to 5,000 pounds with written permission to use is a really big deal for the window cleaners, because certified anchorages on buildings, especially old buildings, are really hard to come by. The 300-foot height limit was a height limit that was put originally into the A39 and then into the I-14, pertaining to wanting to preferentially use powered platforms or scaffolds at those heights or above 300 feet because of perceived risk at heights higher than 300. That has been largely unsubstantiated or completely unsubstantiated, but still somehow this verbiage has found its way into regulation. And then the requirement for stabilization at work locations where descents exceed 130 feet. Intermittent stabilization is a system used with powered platforms where they basically use suction cups or some other method to keep the swing stage from swinging as you get really long lengths, and that intermittent stabilization can be removed as you go back up. But when you're in a rope descent system, there's really no way to remove those intermittent stabilization points. So it really hampers the whole concept. So unfortunately, some of the uninformed users of RDS have kind of come to the idea that, well, shoot, all I need to do to circumvent these requirements is to hire somebody who is, or become myself, a rope access technician that's certified under SPRAT or some other body. Now remember, OSHA's RDS definition says rope descent systems do not include industrial rope access systems, and the preamble says other sections of the final rule, including 1910-28, do cover industrial rope access systems. So the assumption seems to be that by simply becoming a SPRAT certified technician, an RDS worker can fall back on the latitude that OSHA has left here to rope access users. Unfortunately for them, that's not quite that simple. This brings us to part 3 of our discussion, which is management. Again, you're going to recall that earlier we alluded to industry best practice as one of the measuring sticks used to determine the appropriateness of how an employer is doing something. So again, the idea behind industry best practice is that employers need to not only comply with the requirements found in regulation, they also have to remain aware of commonly accepted best practices in the workplace and implement those in a reasonable fashion. So as we recall, according to national and international standards, rope access is set apart by these 3 distinct characteristics: the methods and skills used, the equipment used, and the management. So this is where I'd like to jump to some of the standards and guidance documents outside of OSHA that you might want to consider as useful tools for helping you to build a rope access program into your existing comprehensive managed fall protection plan. Again, I want to emphasize that standards are not regulation. In fact, this slide kind of summarizes how it all fits together. OSHA regulations exist to define minimum safety requirements within a jurisdiction. Here we're talking about the United States, so the OSHA regulations define minimum safety requirements within that jurisdiction. They do so on a very broad scale. Industry standards are specifications or guidelines that are used to measure the compliance with the regulations. So we can use ANSI or other standards to measure how compliant we're being. And then industry best practice are more specific techniques and methods that that we use to perform work in the field. So OSHA fall protection regulations, especially the newest version, as we've discussed, is real performance oriented, and that's a good thing. It doesn't necessarily provide a lot of test methods or specific procedures. And so this is where industry standards, we kind of have to rely on industry standards. Now, voluntary consensus standards, again, are not law unless and until they are incorporated by reference into regulatory language. None of the existing standards that we're going to talk about today have been incorporated by OSHA into regulatory language. So they're just voluntary consensus standards. They're still useful because they can help us to comply with regulation, and they're also useful in providing guidance where there really isn't any regulations. There's a lot of blank spots in there as well. But keep in mind, industry standards, consensus standards, generally provide a baseline for industry best practice. They're the minimum requirements, not the ultimate goal. Understanding that, they can be a useful reference and a useful tool. So we're going to talk about specific ones here as we go on. Some of the standards that are used today that actually call out and address rope access and its requirements are these. SPRAT, the Society of Professional Rope Access Technician, has standards available on safe practices for rope access work, as well as certification requirements for rope access. Both of those are a free download, I believe, at www.sprat.org. The ISO standard, safety requirements for rope access, there's two of those, 22486 is part A and part B, or part 1 and part 2, are safety requirements for rope access. That's an international standard. So several countries came together and wrote these standards, and they're pretty much the standards on which SPRAT and other regulatory or other certification organizations try to follow the internationally accepted practices. ASTM E2505 is specific to building maintenance, but it's a standard practice used for industrial rope access in building maintenance. And then ASSE or ANSI Z359.2, the Comprehensive Managed Fall Protection Plan document, does address rope access, and it does talk about specific requirements and management criteria for rope access, and there's a lot of good documentation in there. And then ANSI Z459, Safety Requirements for Rope Access, is specific to rope access. This document has not yet been published, but it should be coming out soon. We'll talk about that in a moment. Let's real quick jump to Z359.2. I pointed out ISO and SPRAT earlier, and in those standards, there's a baseline requirement that is always applicable at each level of performance. And so the technicians are certified according to different levels, level 1, level 2, so on and so forth. ANSI Z359.2 in its 2017 revision picked up on those levels of training. And really universally, there's no real disagreement on the concept of individuals needing to have verified skills and experience. And the content at the different levels, level 1, level 2, so on, are quite similar between the standards and certification organizations worldwide. So we're kind of getting on the same boat. And Z359, which is the overall, remember, Z359 pertains to fall protection in general. Z359 now actually acknowledges rope access and talks about rope access and how it fits into the overall scheme. In fact, that's kind of the whole reason that SPRAT was formed, so that we could create consistent, measurable criteria to measure technicians' skills. So SPRAT was established in the mid-1990s to inform and educate safety professionals, and it's largely a member-driven organization. It writes standards and certifies technicians, so that's its main function. So just like you expect your ropes and connectors and harnesses to undergo some sort of testing to confirm their performance, and you trust the testing of an outside entity more than you trust the testing of an internal entity, so it is with the humans that are in our system as well. So again, trained and certified technicians are only part of the equation. Where did we go with that? Sorry, trained and certified technicians are only part of the equation. This is the piece that is often a stumbling block to people, and those people that want to jump from RDS to rope access simply by getting a rubber stamp for a technician. It doesn't work, because we need to be using the established methods, the specialized equipment, and the rope access management and supervision that you'll find in some of these standards. It's just not quite as simple as putting a rubber stamp on somebody. Simply hiring or becoming a certified technician is not a workaround. If you want to fall under rope access rules, you kind of need to drink the whole glass of punch, and you kind of need to establish a fully compliant rope access program from the ground up. So this is where Z459 comes in. So perhaps you've heard of ANSI Z359.8 in the past. Point 8 was one chapter of the ANSI Z359 Fall Protection Code, and that code, as I said earlier, encompasses all types of fall protection, and we wanted to include a chapter specific to rope access. However, it was ultimately determined that because rope access equipment and techniques and training and management, they're so different from conventional methods, the committee decided that it would really kind of be potentially confusing to users if we included rope access within the Z359 family, because that's all about conventional methods. So ANSI assigned the group a new number, Z459. The document is actually still being developed under the auspices of Z359. It's still the same committee, the same bunch of people, the same thought processes, but presumably it will also still be included in the fall protection code, but the equipment and the references will actually carry the Z459 moniker instead of 359 so that we can avoid confusion. The goal of 459 is to recognize rope access as a unique skill and with some of the specific requirements of rope access. We want to create separation between what's rope access and what's rope descent. We want to harmonize rope access with the comprehensive managed fall protection plan found in Z359. We want to make consistent requirements with international standards such as the ISO standard. We want to acknowledge and provide guidance for equipment and systems that aren't found in conventional protection methods. We want to go outside of the Z359 process and draw in equipment that you just normally would not find in 359, but you will begin to see in 459. The ANSI 459 document was balloted in 2017, and Z459 received a lot of comments and a lot of revision, and so it's going to be considered or put back up for reconsideration later this year. It's written in the same spirit as the International Standards Organization document on rope access, and it covers all the documents or all the topics that you see here on your slide. So there's a scope, there's definitions, there's program requirements, there's system requirements, there's component requirements, there's qualification testing for the equipment, there's marking and instructions requirements for the equipment, there's inspection, maintenance, and storage requirements for the equipment, and then there's quite a bit on rigging and training for both simple systems and complex systems, which is another presentation that we'll talk about another day. The ISO standards provide guidelines for both employers and technicians, and it's really an emphasis in that effort that results in safety. So the harmony between the employer responsibilities and the technician commitment. Any rope access management system has to have in place procedures for the employer to manage the program using competent supervisors, certified technicians, and an established plan of work. None of those things are optional. They are all required, and they're all covered in the Z459 process. Remember, rope access uses trained certified technicians using established methods, specialized equipment, and rope access management and supervision. Those things are absolutely key. If you're planning to implement rope access into your fall protection toolbox, I highly recommend that you start by encouraging your safety manager to take, or at least audit, a level 1 certification course. If your safety manager is already a rope access certified technician, be sure that they also are well versed in conventional methods of fall protection. And I emphasize both sides of this equation because often the rope access technicians among us kind of went into rope access first, and they don't really understand the requirements of conventional methods, and vice versa. The people using conventional methods and techniques and systems often see things from a very conventional perspective and don't necessarily understand the requirements that exist for rope that are specific to rope access. So highly recommend training, periodic refreshers for both technicians and program managers. I highly recommend that you seek out appropriate certifications for technicians and program managers, such as you'll find at SPRAT.org. Now again, those documents are available. The safe practices documents and the certification requirements document are available at SPRAT.org. Education and training is like the thing that has kept the safety record of rope access so intact. In all sorts of other forms of fall protection, engineers have tried to remove the human factor from the equation. But in rope access, we not only accept the human factor, we actually embrace it, because we know that a well-trained, competent technician working under proper supervision and using established methods and systems, I'm sounding like a broken record here, but this can be the safety manager's greatest asset. So if you're interested in using rope access as part of your comprehensive managed fall protection program, start on the right foot. Look for appropriate certification. Make sure that your managers completely understand, and both your managers and technicians are properly trained and certified. PMI's vertical rescue solutions can also help you develop a well-rounded rope access program, including the documentation that you need to support the program and maintain compliance. So contact Vertical Rescue Solutions if you'd like help writing a comprehensive managed fall protection plan for rope access. And if you want to study it on your own, there aren't many reference books out there, but this one on the screen is Professional Rope Access, A Guide to Working at Height, is one that I wrote a couple of years ago, and it was published by Wiley. It's actually the only reference manual that I know of out there that covers everything from regulatory guidance to equipment, systems, pre-planning for rope access. There's actually a whole section of the book that's dedicated to the comprehensive managed rope access program, and it includes worksheets and forms to help guide the process as well. So, as I said, it's published by Wiley. It's available from your local PMI dealer or whatever. And always, always, always at PMI or at Vertical Rescue Solutions, we are here to talk. We're here to receive your calls. We want to know what we can do to help you. Unfortunately, I'm afraid we're out of time for today, so I'm going to have to wrap this up and turn things back over to Jeff. But hopefully we'll have a few moments to get into whatever questions you might have. And again, please communicate with us as far as what we can do to serve you better. Jeff?
All right, Loui. Thank you very much for that very informative presentation. Now we will take time to answer some questions that we received during the presentation. So we'll jump right into that. The first question is, how do rope access organizations like SPRAT and IRATA interface with either federal OSHA or state level OSHA when there is a potential citation of a certified rope access technician for noncompliance?
That is actually a great question, and it's actually how SPRAT was formed. Back in the olden days, back in 1996, before some of you guys were probably born, I was working for PMI at the time, and part of my job was to we were PMI was actually the importer of and distributor of Petzl equipment at that time, and part of my job was to defend people who were using vertical rope work on structures and buildings, and getting cited by OSHA because the system didn't fit their preconceived idea of what fall protection should look like. And in having those conversations with OSHA, they kind of were of the opinion that, well, that's all well and good, Loui, you're one person and you have a great perspective, but you're only one person. So that's how we drew SPRAT together and said, well, okay, I know I'm not the only one that feels this way. So we literally sent a bunch of letters out to people and said, hey, does anybody else have this problem? And got a boatload of feedback from people, and SPRAT was born. And so now a big part of what SPRAT does is if somebody's struggling with a citation or an issue, we can come alongside you and help to translate both for you and for OSHA what techniques are being used and how that complies and where it fits. The best place that we can do that is to do it in advance, because you can do rope access safely within the context of OSHA requirements. If you get cited by OSHA these days, chances are you might not have been doing rope access right. So that's just a caution to try to address that issue before it happens. But we will actually work with OSHA and reach out to OSHA and talk with OSHA on your behalf. In fact, we reach out to and talk to and spend time with OSHA regulators before accidents or before citations ever happen. We're in constant dialogue, trying to improve the workplace, both for people who are doing rope access and other people at height as well.
Okay, great. Moving along to the next question. In Z459, how do simple and or complex systems relate to level 2 and level 3 supervision in SPRAT?
That's a great question. The ISO standard actually separates simple and complex, and I don't know. I know that SPRAT is making changes at this time to their requirements, but I don't know for a fact that they're adopting the simple and complex terminology, although I hope they do, because other standards organizations worldwide are. So the simple system is basically a straight up and down system. So a straight up and down system is any rope that's just hanging vertically that you can go straight up or straight down without passing a deviation or a re-anchor in any way. A complex system is a system that is deviated or re-anchored. It's a system that doesn't have egress at both ends. So for example, working over the ocean. If you're dangling over the ocean, that would be considered a complex system, even if the rope just goes up and down, because you don't have egress at the bottom except into the water, which we assume you don't want to do. So the simple system pretty much is a level 1 type system, and that's kind of how the requirements are written. The level 2 and above is required to do complex rope access. And the supervision has to be obviously in alignment with the capabilities of the people doing the work. So if you understand complex systems, you understand simple systems. If you understand simple systems, you may or may not understand complex systems. So being able to work within those different categories is a big part of where the whole industry is going worldwide.
And in simple and complex systems, they're both two rope systems as well. Just to be clear on that as well,
Absolutely.
right? Okay,
Absolutely.
always in rope access. Right. Okay, next question. How do rope access technicians differentiate between fall arrest tools, techniques, and regulations versus the same considerations for rope access when accessing their anchors when approaching a typical rope access job?
I'm not sure I completely understand the question, but what I think I'm hearing is how do rope access technicians do the transition between fall arrest and rope access when there might be different requirements for fall arrest versus rope access?
Yeah,
And
that's
I think that's kind of where that question is headed. Is that
about
right,
right.
Jeff? Okay.
Yeah, that's what
So
it looks like to me.
Okay, so in general, when you're dealing with anything regulatory, the most prudent course of action is to adopt the most stringent requirement. So if you know that you're going to be moving in and out of fall arrest, for example, then it's best to, and if there are higher requirements for that, then you should comply with those requirements while you're in that system. When it's an anchor, you're not going to change anchorages between your fall arrest or your rope access. So that anchorage is going to stay a fall arrest anchorage the entire time, even though you might do rope access on it. So you're going to pick the most stringent requirement, and then you're going to use it as the guiding principle by which to do all your other work.
Okay, great. Um, okay, here, next question. Does OSHA identify specific criteria that constitutes a fall, where a personal fall arrest system and components would be required to be removed from service?
I
So the first,
don't
it looks
believe
like
so.
there's two.
It's not in regulation. I'm just kind of scrolling through my head in regulation. I don't believe it's in regulation. The only place it might be is in an interpretation, and I can't seem to recall anything in an interpretation either. So that's actually a really good question, because what you might perceive as just what do I want to say? Maybe a rapid loading of a line might would that be considered a fall in OSHA lingo? I think is the concern, and it's a valid concern. I would suggest that at that point you go back to the equipment that you're using, and no pun intended, fall upon the requirements of that equipment. So if the manufacturer of the fall arrestor, for example, says if you take more than a 300-pound hit to this device, then it's a fall. You can use that as a guideline. Z359 will actually also have a little bit more to say in that regard, at least in as pertains to harnesses. You'll find now that there's a fall arrest indicator on harnesses that actually pops out if the harness is loaded above its allowed amount, which I believe is 900 pounds. So that's a useful tool there.
Okay, and are all carabiners now required to be ANSI gates?
No, absolutely not. ANSI is a test method and an equipment standard. And so OSHA does not specify ANSI anywhere. However, OSHA does specify a 3,600-pound gate. So if you choose to get to a 3,600-pound gate by using an ANSI certified carabiner, that's a great way to ensure that you're using a 3,600-pound gate carabiner. If you can find another carabiner that's not ANSI certified that has a 3,600-pound gate, that would actually also be OSHA compliant. So remember, standards are just a way to achieve compliance. So the technical answer to your question is no, it doesn't have to be an ANSI carabiner. But I think that what your intent is do they all have to be 3,600 pounds? And the answer is yeah, I'm afraid so.
Okay, thank you. Next question. How does rope access organizations who deem their certifications as third party justify the assessment as third party when the trainer selects and compensates the assessor?
That's a great question, and it's a topic that is in debate in standards organizations worldwide at the moment. The the person who pays anybody who does work is paid for that work. So for we're talking from PMI today. At PMI we manufacture life safety rope and harnesses and other equipment for rope access and rescue at height, and we pay somebody to certify that equipment. So that equipment that we send to underwriters laboratories gets tested according to the standards that we ask for, and then it comes back with a test report. If that test report is marked pass, we get to pay. If that test report is marked fail, we get to pay. So the payment of the fee is not dependent on whether or not there's a pass fail. It's the same in SPRAT. So even though at this time the SPRAT, testing people, the people doing testing, the testing hosts are allowed to choose their own evaluator. At this time, that evaluator gets paid whether the student passes or fails. And so that is considered a third-party agreement. Also, if the that third party does not actually work for the host where the testing is being done, he actually works as a subcontractor to them or as a separate entity to them, and it's via SPRAT. So not just anybody can certify. There's actually a process that people have to go through SPRAT to become evaluators, and everything is done under those SPRAT guidelines.
And there was,
Although editorially, I will agree with you that I think that someday it would be really cool if SPRAT would assign evaluators. But I work for PMI, not SPRAT, so we'll see what SPRAT does with that.
and it sounds like you answered. There was kind of a second part to that question where it asked essentially, can trainers do the assessment themselves
There is
for
an
level
allowance.
one candidates?
There is an allowance for that in the level one candidates, and the intent of that allowance is that if an employer has a full rope access program and he's got level ones, level twos, level threes, and he's bringing level ones in to work just in his environment, in his limited scope, that he should be able to certify those technicians for that work application. Now, whether or not that allowance gets abused, I don't know. I don't have any experience in that. PMI's training entity is Vertical Rescue Solutions, and we never utilize trainers as evaluators. We always hire in a third-party evaluator and we use multiple different evaluators from across the country over the course of the year. We never use less than 3 or 4. I think we're up to 6 or 7 already this year, just for exactly that reason. We feel like it brings honesty to the training program.
And we got a little follow-up that preaches some enthusiasm for your answer on that on that question.
Nice.
So
Nice.
thank you for that. And it looks like the last question we have here is kind of shifts gears a little bit. And can you comment on rock climbing instructors and how OSHA might interact with that sort of work at height application?
Oh, this has been a really awkward one, actually, because of the recreational, not just rock climbers or guides. Guides and mountaineering guides and ropes courses fall into the same kinds of categories. Climbing gyms. Why should the route setter have to be wearing a fall arrest harness while he's setting routes, and then he can go climb the same route like he can go lead climb with a bigger fall, the same route in a seat harness. It is a big can of worms. And in general, where it seems to be going is, and ACCT, the Association for Challenge Course Technology, is actually trying to address this in their new ANSI standard, which I don't know what the number of that is off the top of my head, I'm sorry, but ACCT is trying to address this from the perspective of the person doing the work should be in at least as much protection as the person that he's guiding. So when it comes to recreational pursuits. Now, that said, there have been situations where people have been cited, like people guiding and setting routes for recreational facilities and guiding recreational programs have been cited for not being in conventional fall arrest methods. And that is very, very awkward. We believe that what seems to be happening, well, that's two different terms. What seems to be happening is that more and more of these people are using rope access. And we believe that rope access is actually going to help provide a bridge for some of these workers. Because in truth, when you're working in many of those environments, like the challenge course, you're more comfortable in a full body harness anyway. Now, that's not necessarily true for mountain guides, and that will always be a dilemma. But for the moment, OSHA seems to very much leave those guys alone, and I hope it stays that way.
Great. There is actually one more that came in. One more question. I think it's worth discussing if we have time for one more question here. I think we can
We do.
squeeze it in. Okay. Here's the question. Do you mind commenting some more on certified anchors? Now, is there a provision where the contractor can pull test the anchors? And does every anchor have to have 5,000 pounds of force applied?
Now you're getting out of OSHA and into how the testing is being done. So remember, OSHA has the requirement, and OSHA's requirement is that the anchorages have to be confirmed to a certain strength. That they don't necessarily say how that has to be done. So at this time, whether a professional engineer analyzes and does a proof load at some force smaller than 5,000 pounds is the way to do that, or whether pulling it to 5,000 pounds is the way to do that, remains a huge topic of debate. Now, personally, I think that if I have a 5,000 pound anchor, the last thing I want to do is pull it to 5,000 pounds. You guys climb on ropes all the time. You get a PMI rope and it's rated to 6,800 pounds. Do you really want me to pull it to 6,800 pounds to prove to you that it's a 6,800 pound rope? Probably not. You probably want me to make that rope. You want me to make a bunch of those ropes and then test a bunch of them from different lots so that I can affirm the performance of that type of rope and then make the same rope the same way time after time after time after time and have a quality program that proves it. In the same way, anchorages, if you pull anchorages to a really high load, you're going to do some damage, not just to the anchorage, but to whatever the anchorage is connected to, or not just to the anchorage connector, excuse me, but to what the anchorage is connected to. So it is a big topic of debate at the moment. Some people do read the requirement as it has to be pulled to 5,000 pounds. That's a really scary way of reading. And I hope that somebody has written OSHA a request for clarification on that. And I'll just plug that while we're here. If ever there's anything in this regulation or any other that you're not really clear on, all you have to do is write to OSHA and ask them for an interpretation, clearly outline your question, and they will, it might take weeks or months, but they will compile a response to you and interpret their intent for that. Again, I'll go back to the requirement, or to the recommendation that I made earlier of reading the entire document, reading the entire prologue and the whole new rule that's out there, by reading that rule, you can really begin to absorb what OSHA's getting at and what their intent is in making the rules the way that they're making them. And understanding that intent can actually help you be way more compliant. And on a related note, and kind of leaning back to the discussion we had a minute ago about the mountain guides in seat harnesses, if you're in an industry that isn't regulated, that doesn't have something written, write it. Get with whatever your professional organization is in your industry and write it down, get it written and justified and explained so that you have documentation to bring to OSHA to say, hey guys, we're not following what you guys see as the regular rule, and the reason that we're not doing it that way is because it's more dangerous, and here's the safe way that we're doing it. That's exactly what we did with SPRAT. That's exactly how SPRAT started. And 30 years later, or maybe less than that, 20 years later, it's actually a viable, accepted means of work. So it'll take some uphill climbing, but it's well worth it.
And yeah, this has spurred on some really good questions. And I guess one more question would be, do you think an aspect of OSHA will move into technical rescue for SAR applications, search and rescue applications?
Eventually, I do believe so. The interesting thing, though, is that most search and rescue is done by volunteers, and volunteers are excluded from OSHA. That said, there are professional entities doing search and rescue, and there are fire departments doing search and rescue. And I can tell you right now that was it 2 or 3 years ago, OSHA did put out their feelers for information on regulating professional responders. And so it's not a matter of if, it's just a matter of when. And I do believe that that is in the works and that it will come to light sometime in the next. The good thing is things really move slow in bureaucracy, and so it may be another 20 years before we see this stuff. But I know that they're currently working on how to approach emergency services responders. And when it comes to the emergency services responders chain, search and rescue, we're kind of down there at the bottom of the list. We're low on the food chain because A, there aren't very many of us, and B, we don't get hurt very often. So and C, we're all volunteers, or most of us. So there's some consolation there, but as we all demand to get paid for what we do, there's more and more paid volunteer firefighters in this world than there were 20 years ago, and I think that's becoming the case with all emergency services. So I do think it's coming.
And just to kind of as a final here, is there any? Do you mind directing towards any other standards to learn more about testing procedures?
Oh, I don't remember the number off the top of my head. So there's different kinds of testing. The only standards that really exist for testing are lab testing. And so laboratory testing is verification testing to prove the performance of a certain class or category of equipment. And so whatever industry you're in, there are probably test standards to go along with that industry. In fall protection, the big one is ANSI Z359. That's the most commonly accepted and recognized standard for equipment. In ANSI Z359, there's a section or a chapter of Z359 called Z359.2 that talks a little bit about testing and verification testing and some of the baseline requirements for that. The actual test methods for different pieces of equipment are found in the standards themselves. So you'll, depending on what you're doing, there are some places that you can go. That said, one of the most valuable kinds of testing that I think exists in the world is, standing at the edge of a bridge and tying a rope to something and nudging it off and see what happens. So go out and simulate the kinds of work that you do in a safe way, of course, and see what happens in the event of a failure. Confirm your suspicions, because all equipment testing can do is confirm what that individual component will do under laboratory conditions. It can't predict what it might do when it's connected to something other than a test machine, like a rope or another carabiner or a shackle or anything else. So, so verify that. The other thing that I will just go ahead and take this opportunity to mention, since somebody opened the door, is there's some different requirements in the testing realm for equipment. ANSI Z359 equipment is typically what we choose for fall protection related type work. For rescue type work, we often lean towards NFPA and related standards. Now, NFPA actually has a third-party testing requirement. They say that you have to have a third party, like Underwriters Laboratories or somebody, do your testing and get a test certificate from them. ANSI Z359 doesn't say that. A lot of people believe that it does say that, and in fact, we actually tried very hard to get it to say that, which is kind of a stupid thing to do as a manufacturer, but we believed in it, and so we felt like that was the right thing to do. So we really tried to get a third-party testing requirement into the ANSI process for Z359, but that did not happen. And so as the standard reads, manufacturers are allowed to self-certify equipment to ANSI Z359. If you want to verify that, you can always ask them for their test records or ask them for their proof of verification forms or whatever. But just as a word to the wise, just buyer beware.
Okay. Well, Loui, thank you so much for such an in-depth knowledge of this subject and all the detailed answers to all of the questions that our attendees had today. Do you have any final thoughts for our attendees?
Well, I'd just like to thank everybody again for being here and for taking the time to chat about rope access. It's definitely one of my favorite subjects. And so if you'd like to download this presentation, obviously you can go to pmirope.com later and do it. Always, PMI is happy to be contacted anytime. Jeff's here, I'm here, Tom's here. Lots of us are standing by. Just love to chat with you if you want to give us a call anytime and talk about any of this stuff.
Great. Well, thank you very much. And we really appreciate everyone attending today's PMI Technical Webinar Series. We will have, we plan to do at least one webinar per month on technical subjects such as this. And so keep your eye open for the upcoming webinars. And as Loui mentioned, this webinar has been recorded and will be available at pmirope.com. With that, we're going to say goodbye today, and thank you for attending. Until next time, goodbye.